Good morning. I am Dr. M. Sreedhar, Professor of VNR JYOTHI Institute of Engineering and Technology, Hyderabad. I would like to take a lecture on power plant instrumentation. This power plant instrumentation particularly deals with energy sources. How we are able to convert these available energy sources into an equivalent power. So, the primary objective of this power plant instrumentation is what are all the instrumentation equipment such as the sensors, transducers, controllers, till final control elements and control room instruments. We need to focus more upon instrumentation. As a part of this, we will begin the course from energy sources. So, what are the energy sources? We have the available conventional energy sources and non-conventional energy sources basically. The first category, conventional energy sources, are also called as non-renewable energy sources, and the non-conventional energy sources are also called as renewable energy sources. For example, solar power is there. Similarly, thermal power is also there. All these existing depending upon the availability of energies. So, solar power is able to renewable time to time, whereas the power that is generated based on certain fuels with different calorific values like coal or bituminous coal, lignite, all these things are generating certain energy, but they are unable to renew again. Hence, these are categorized into conventional and non-conventional energy sources. Whatever may be the energy source, we need to study aspects relating to how these energies are being converted into power. Depending upon type of energy sources, we have wind power, we have tidal power, we have the other sources, magneto hydro power, and many other power generating sources are there. However, today we will know about what is a thermal power plant. Basically, thermal power plant consists of boiler. Hence, it is essential to know about boiler instrumentation. The boilers basically has two types. One is fire tube boilers, another one is water tube boilers. Here, heat exchanging principles. After generating an energy of certain temperature, that is being transferred to the existing water, and that water is converting into steam. The basic principle of a boiler is we have to use the available raw material sources such as fuels. These fuels are having different types of calorific values. Sometimes for the purpose of utilization of other industrial sources such as rice husk or peanut husk, all these things can also be used as raw materials or as a fuel in order to generate the steam. However, after generating the steam from these boilers, it is again essential to increase the temperature of the generated steam in order to make it compatible to rotate the turbine. Therefore, let us focus our attention on boiler instrumentation. The boiler instrumentation particularly consisting of a water drum as well as another one is, in addition to the water drum, we have the feed water lines, steam output lines, and superheater systems, fuel handling sections. Like this, the power plant having different sections. Fundamentally, we need to get the water from rivers or nearby water sources. Therefore, it is essential to first of all investigate about the water sources and availability of other raw materials near to that plant in order to meet the profit and other economical constraints of the power plant. So let me draw the basic overview of a boiler instrumentation. Basically here we have a boiler. This is the water drum, and here we have a valve, and I can represent this as FW, which is denoted as feed water. And here the other parts of this boiler are a series of pipelines which are carrying these pipelines till header. And here we can see this is the header, this is header, this is water drum or steam drum, we can say steam drum. This is the generated steam. And here I am representing the fuel line because we need to generate heat with the help of this fuel. And here is the air fan. So we can call this as a FD fan or forced draft fan. We can abbreviate this FD as forced draft fan. However, the generation of steam is having 100 degrees centigrade here. Again, to meet the requirements of next stage turbines, we need to heat the steam with the help of the flue gases. So here all the temperatures that are coming from this furnace. So I can write this is the furnace where the ignition will happen because I am sending the fuel here and air from this direction. So in order to make combustion, all the fuel along with the air with the control, here also we have certain air to fuel ratio control we will use, and this heat is being subjected onto the header where the water particles are coming down, and again the steam particles are going onto the top of the drum. So while they are traveling from header to water drum, this is converted into steam, and this steam is further heated with the help of a set of superheaters. So we will receive the high temperature from the fuel gases or the waste gases that are coming from this fuel system onto the superheater, and here is the steam to turbine. So here we can categorize this as one FW. This is nothing but feed water. Second one, I am using FD fan. This purpose, this is called as forced draft fan. And here after combustion is over, certain flue gases, all these things will go away with the help of a chimney. Here I can draw a chimney also. Let me draw the chimney here. So this is a chimney. So all the waste gases, all these waste gases will flow into the atmosphere. However, we need to regulate the concentration of those toxic gases, particularly they are releasing into the atmosphere, which should be in the safe zone limits so as to protect the people who are living near to the power plants. For this purpose, the chimney is having ID fan. ID fan. This is nothing but induced draft fan. Induced draft fan. So the purpose of this induced draft fan is it will suck all the waste gases and send to the atmospheric. So here we are learning the feed water, forced draft fan, ID fan, and we have water drum. Here we have flow regulator and controller is there, because unless we control the feed water flow or temperatures, it is a little bit complex to control the steam flow, generated steam flow, because we are going to follow different control methods for this boiler instrumentation, such as the steam can be controlled by regulating the level of the boiler as well as the feed water. Then we will apply feed water and feed forward and feedback control systems also. Hence, before this feed water line, we have analysis equipment, because the water is to be analyzed properly. That's why we have another plant called as analytical plant. The purpose of this analytical equipment or analytical instruments is to evaluate various types of volatile material or organic or inorganic or salts present in the water, so as to make the feed water perfect to not contaminate the inside vessels of the drum as well as pipes. That's why we need a proper analysis of various chemicals. Upon completion of the analysis treatment, then the steam is being converted into the power. Before that, it is given to a turbine. So in this turbine also we will get the condensate water. Another one is condensate water. For this purpose, we will send cool water onto these lines so as to condensate the steam that was utilized inside the turbine. So then it is condensed water. Here I will write condensed water. So we have feed water, condensed water, and also we have makeup water along with these two. That we will discuss. Upon completion of complete boiler instrumentation, let us concentrate upon the measurements associated with the water circuits. Here, for the efficient operation or uninterrupted operation, we need to achieve the stable water circulator system to implement the automatic systems. For that purpose, we will use 4 basic, not only 4, the other things are also there, such as first of all the boiler drum level control. Another one is superheater steam temperature control, steam pressure control, steam flow control. In addition to that, we have water flow measurement, because we have different types of waters associated with these circuits. Raw water is one water, another one makeup water, condensate water, feed water, of course we have studied, and the cooling water. The purpose of this cooling water is to obtain the condensate water from these turbines. By sending the cooling water, we will get the condensate water. So upon mixing this condensate water with the raw water, then we will have a makeup water also. So that is other study related with these types of waters. In addition to that, at various points we need to measure the steam flow after the steam is obtained from the boiler. Another one is pressure measurement is also an important aspect. So this is particularly in water as well as steam lines at different points. Another measurements associated with this boiler instrumentation is temperature measurement. Particularly, this is also for water as well as steam at different points within the boiler or thermal power plant. Level is also playing an important role in boiler drum, and another one is the deaerator. So let us see how water flow can be measured in thermal power plant. Here an important instrument like differential pressure transmitter DPT head sensors are used. So DPT is nothing but differential pressure transmitters. They are used for flow measurement. However, all the flow measurement techniques based on Bernoulli's principle that deals with the hydraulics and fluid mechanics. And here DPT head sensor, the sensors example are given here: orifices, venturi meters, and V notch is also there, or sometimes a flow nozzle. Like this, we have different types of sensors we will use for the measurement of flow. Normally, the principle of Bernoulli, what he said is, by taking a pipeline which is carrying a fluid kept at an elevation, it can be divided into two sections. One is the upstream side and downstream side of an obstruction that was placed inside a pipe. So before the obstruction side, we can call this as upstream, and after the obstruction it is called as downstream. What Bernoulli said is, the summation of pressure head, velocity head, elevation head at upstream side is equal to the same parameter summation at right hand side. So finally, he made a relation between Q and H, where H is the differential pressure or pressure head we can call, and Q is the flow, and K depends upon the sensor constant or a constant related to the design aspects of the sensors. We need to install the head type of flow meters. So fundamentally, the sensors related with orifices, venturi, dal tube and other things, whatever it is, we need to situate an obstruction in the path of the flow within the pipeline, whether it may be water carrying or steam carrying. So how to install it? Later, based upon the sensor output that is coming from orifice, venturi, dal tube or the pipette tube. Of course, this pipette tube is used for the measurement of flow in submarine related studies. It deals with stagnation pressure and static pressures. Here, upon completion, upon getting the head signal from orifice or venturi, any other kind of primary elements or sensors, these are, that will be connected via a transmitter, which is nothing but DPT, which is differential pressure transmitter. What this differential pressure is? Let me draw here. Suppose a pipe is carrying a flow. This is flow in and flow out. And if we keep an obstruction, this obstruction is nothing but whatever the listed here, orifice or venturi, anything with different designs. The designs may be different. So this side portion we will call as upstream, and the right side of this obstruction is called as downstream. So we will have different pressures. Here is suppose P1 and here is P2. What happens if I am sending the liquids or the water particles? All these particles are flowing at this point, And again, that means all the fluid particles will converge at this point. And this, after the obstruction, again all the flow particles will diverge. So at a particular point, we have the maximum pressure and minimum velocity. And minimum velocity of fluid particle. This is called as vena contracta. So development of this P1 and P2, which is nothing but a delta P, I can write P1 minus P2. This P1, P2, we know that P is equal to rho GH. Here H we are developing, head differential. And by considering the rho as density of water and G is the gravity constant, by using this formula I can calculate P1 at upstream side and P2 at downstream side. This difference finally I am giving to a DPT, differential pressure transmitter. That means whatever may be the flow rate Q, this I want to convert into electrical form, into an equivalent current or voltage terms. Therefore, I need a DPT. So here the DPT purpose finally is to convert the differential pressure into a equivalent electric signal and can transmit. It is not for the local indication. Local indication is at that point indication, but here we can transmit the differential pressure signal which is calibrated in terms of flow rate, and it can be sent to the control room. And installation, how to install this DPT? It is a complex, little bit a complex job. It needs particular practice of engineers and technicians. So installation of this DPT depends on location of the sensor and what application. That means that DPT is dedicated to measure which fluid pressure differential. Installation of head type sensors. If we are unable to install properly, then it leads to serious errors. Therefore, we need to take utmost care at the time of installation of DPTs associated with primary devices. So here pressure piping is an important. Pressure piping is done between pipe tappings of head, producer and DPT. So another one is improper pressure piping will also yields false reading due to air and vapor will be locked. Therefore, we will use tappings related to the water carrying pipelines. The same thing can also be done for steam carrying pipelines. Then we have to use pots. So as per the design considerations are required, we need to install the DPT below the pipeline installations. That means suppose we have a pipeline is indicated and this is the obstruction or orifice. We can, this is an orifice. And here it is P1 and P2. I have to use valves like this. This slope is not less than 1 by 10, so as to release the locked vapor inside it. So this is nothing but this is the DPT. Finally, here you will see DPT. This is the DPT. That means whatever the wet particles or vapor things are there, that will be released here with some root valves are also present here. And finally, differential pressure transmitter will receive the input pressure differential signal, and this signal is converted into an electrical equivalent. So a horizontal distance is too long to allow this slope. First take the pressure pipes below and raise the above, and this is the common procedure in order to install successfully. A DPT can also be installed on top or above the pipeline. So it appears, if it is the pipeline, so somewhere here it is also not less than 1/10, and we will use root valves or check valves here, and the DPT can be installed like this. So these are the procedures how to install differential pressure transmitter. So what are the various specifications of differential transmitters? Here the input, if it is a water, flow rate is the input. The specifications of DPT is basically 4 to 20 milliamperes DC signal we will get. That means suppose this is the DPT I am using. DPT, the input, as you know, it is coming from the difference of P1 and P2. Here I am getting 4 to 20 milliamperes. This 4 to 20 milliamperes must be compatible or analog to the input flow rate here. Here if I am going for a flow rate, or if it is a pressure signal, directly the pressure signal, say 0 to 10 kg per cm square. I want to convert this 0 to 10 kg per cm square pressure into 4 to 20. That means 0 is the minimum and 10 kg per cm square is the maximum. Corresponding to this input, the output of DPT must be 4 milliamperes corresponding to 2 and 20 milliamperes corresponding to 10. That means full range. And here is the question, why can't be this 4 is 0 milliampere? Why we are taking this 4 milliampere instead of 0 milliampere? The reason is that if you protect the characteristics of pneumatic sensors, that is a electro-pneumatic converter, that means air pressure is converting into current. The graph we will get is, that means suppose this is 0 and this is say 100 psi, and output is current, and this is 4 milliamp, this is 20 milliampere. This is the linear portion. So in these characteristics, the linearity obtained from 4 to 20 milliamperes, which is the reason for choosing this for minimum and maximum values. However, DPT needs a DC voltage supply, 12 volts to 42 volts. It uses 2 wire, and there are nowadays, with the advancements of the smart technologies or advanced computer programming technologies, AI and other things, the designs can also be obtained in a smarter way. It is essential to linear this current of the transmitter to the flow rate. So it is very important, as I told you, this 4 to 20 milliamperes must be linearized to the proportional current of this transmitter or flow rate. For this purpose, we will use square root extractor internally built. So this is about the water line. Coming to another section, this is a steam flow measurement. Because the boilers, first they are taking feed water as input and flowing into the water drum, thereby receiving the heat from the furnace system and generating the steam. Now this steam is generated. Of course, it is sent to the superheaters. Before that, it is essential to know the steam flow also. That's why the steam flow in individual boilers is also important. Total steam generated by the plant, steam consumption in boilers, the other process steam requirements. Steam flow methods are almost the same as water flow measurements. One or the other way, both are related. That is the reason why some of these flow methods are common to both water as well as steam lines. An important point in regard to the boiled steam is the boilers are specified as TPH as their units. The TPH is tons per hour. Normally, thermal power plants are designed with more number of boilers instead of single boiler. The boiler stages 1, 2, 3 up to, depending upon the capacity of that particular plant, we have more number of boilers. These boilers individually generate depending upon its TPH value. That is nothing but tons per hour range. All these generated steam is collected at one point or one unit. This unit is called as steam bus. Depending upon power requirement, normally we need a stable power without any alterations or without any improper or quality. That's why electrical engineers need to maintain power factor related with this. However, all these steam generated from individual, say n number of boilers are there. All these n number of boilers will feed their output steam into a unit called as steam bus. Depending upon power requirement, this steam can be drawn from steam bus. In order to save the fuel or every time switching on the boiler, depending upon demand of the pressure, we can start some boilers out of n boilers. If more power is required, more boilers are need to be switched on. If less power is required, only few of them can be used. So in this way, steam bus will do its work in selecting, in utilizing various turbines, or to which turbine it has to give the power. Coming to steam flows, we have condensation pot. These are connected to the pressure taps. So earlier we thought that is water taps are there on the pipeline. Here it is nothing but pots, condensation pots will use, because the steam, when it is cooled down, it is converted into water. So we need a pot to collect them. These are connected to the pressure taps and adequate size to supply enough condensate and to ensure high columns above the flow meter. So these are the designed aspects. Here also we have condensation pots for vertical and horizontal steam lines. Normally the condensation pots are manufactured depending upon pressures with cast iron materials, carbon steel materials, stainless steel and molybdenum are also used based upon the pressure. Here 100 kg per cm square. 64 kg per cm square, the unit. So depending upon the capacity, we can use these different types of materials. So like this we have steam pots and condensation pots. It is nothing but condensation pots for perfect installation of these DPTs. In addition to this, we have temperature and pressure corrections that we will discuss in the next class. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.